how's it going, guys? We're going to do problem 347 today, which is the learning log that follows this assignment over here. So hopefully you've gotten a chance to do this assignment, ideally with your group or ideally in class, one of your meetings with your teacher. It's kind of introduced you and allowed you to spend time on these things. So what you did in section 3.2.2 was you explored something called an area model. So the idea is that through our tiles and through our algebraic expressions, if you're able to take, say, like a jumbled pile of algebra expressions and algebra terms, and you're able to create, looking at this pile right here, and create a rectangle out of it, there's actually two different ways you can name that collection of tiles, that collection of algebra terms in that expression. You can write the name of these tiles right here, the name of that algebra expression, as a sum or as a product. So as I have over here, things that I definitely want to talk about today when we do the 347, the learning log together, I'm going to want to talk about that word sum, and I'm going to want to talk about that word product. Okay, so in 345, hopefully you got a chance to build it and understands what is a sum, what is a product. If not, we'll review in a second. And then in 346, these were actually all rectangles, right? You could have taken these collection of tiles, and it could have been a jumbled mess at the beginning, but using the online tool, there's a way, for instance, if you put that x squared in the bottom left corner, then you can figure out a way to stack those three x's and the two ones in the top right corner to form a rectangle, and then name it based as a sum or as its product name. And these will be very important because all year we're going to go back and forth between the two different forms, because x squared plus 5x plus 6, for instance, is equivalent to the quantity x plus 3 times the quantity x plus 2. And we could prove that by actually doing the multiplication now, but that's not what we're concerned about today, which is learning log 347. So without further ado, I'm going to read learning log 347, and I'm going to take a look at the tool for playing with algebra tiles, because I'm actually going to set up a rectangle just like this with you guys over here on this side. This is where we're going to set up our rectangle. Okay, 347 learning log. It says make a rectangle from any number of sides. As long as you can make a rectangle, you should be able to know how to write it as a product and as a sum. So that's kind of what you're doing here in the learning log. Anyways, your rectangle must contain at least one of each of the following tiles. So they're going to have a whole bunch of tiles in this one. We're going to have an x squared. We're going to have a y squared. We're going to have an xy piece, an xy tile. We're going to have an x tile. We're going to have a y tile, and finally a 1 tile. So all 6 of the tiles that we're using here in Algebra 1 will be represented, and we have 6 different types of terms. None of these terms can be combined to one another because they're different types of terms. We got our 1 piece, and y's, for instance, can't be combined. This will be the sum y plus 1, for instance. Okay, so now I have these tiles, and it says that I need to make a rectangle. Well, let's see if I can actually take this and set up a rectangle with these pieces, or if I'll need more pieces, because if you noticed here, it says at least one of each of the following. So let's see if I can get this here. Well, I have a y squared here. Usually you want to do your biggest square to the bottom left, because then you can build on top of that bigger square. You can figure out what goes next to it. So for instance, I could put a y here. Sure, I could put a y here because y have the dimensions 1 times by y. And so a length of y will get matched up perfectly. And this would be a rectangle right here. This would be a rectangle. So we could write this as a sum and as a product, but we haven't talked about the other tiles yet. Okay, so I'm going to put that there. And it looks like I can actually place this here because remember an XY, the reason why we call it this tile the XY tile is because it's the product of X times by y, x times by y. So it's named after its area, right? Length times width, the simplest we can write length times width, its name is x times by y. Okay, so at this point, it looks like I can't keep stacking this way because this isn't a rectangle. This is something different right here, okay? So could I have stacked this way to make this a rectangle? No, I couldn't. That x piece isn't going to line up with anything. Look, this doesn't really line up at all. We don't have ourselves a rectangle. So what do I have to do? I got to get some more pieces here, okay? I got to get some more pieces here. So I got to figure out a way to talk about x. Well, maybe we can put our x's over here. That's possible, right? We could put an x there. We could put an x there. We can put a 1 there, for instance. that's maybe getting us started up with a rectangle. Let's see if we can finish it out here. How can we finish this out, potentially this rectangle? This one might be a little bit messy here. Okay, let me move in a y, because remember a y here, if we have a 1 here, we need a piece here that's going to be the dimensions of 1 to line up with this one piece, and y to line up with the y squared piece. And I'm going to go ahead and flip that and place it right here. Okay, I'm going to place it right there. And then what else is missing? It looks like we have another x that would be missing here, and we would have an xy piece would be up here. An xy piece would be up there. Okay, so this is a rectangle right here. We can write this rectangle as a product or as a sum. There are 2 different names for this here, and they're equivalent to one another. Okay, so it says make a rectangle from other sides. Your rectangle should be this. It says sketch your rectangle in your learning log and write its area as product and as a sum. So we're going to do this one. I chose kind of a more difficult one than maybe you did here, but let's go ahead and see if I can try to sketch this out. So it almost looks like a square. Let's see if it's a square. I'm not totally certain if it's a square or not. I'll have to look into it a little bit more. Okay, bottom left corner is that big guy. That's the y squared piece. Then we had a y piece on top. Finally, we had an xy on top here. A few things I might be doing as I'm kind of going through this is perhaps I'm writing the outsides of the rectangle, because the outsides of the rectangle is where we're going to find our product here. Okay, so this is y squared because this length here is y. This is y because it has a width of y, just like the y squared is right here. It's a width of y, but it has a height of 1. And y times by 1 is y. Here, right, we know that this is a width of y, and this is a height of x. And that's why this piece right here is that xy piece. All right, so we're starting to get the dimensions on the outside, starting to get them on the inside too. We have a y here, we add a 1 here, x and x squared. Apologies for this, doesn't really look like a square up here, but kind of the best I can do. Maybe I'll erase this here. And there we have it. I have my rectangle that I've set up. Just need to get the outside now, and I have a 1 here. And because this is our xy piece and we already have y being the height of this, that means the width here has to be x. And it checks out here, top right corner, x times by x would equal x squared. So, so it matches up here. Okay, so I've actually built a square. I know it's a square here because notice this here. Look, our width is identical to our height of this rectangle. And a square is a special type of rectangle where all 4 sides have the same length, and that would meet the definition of the square here. Okay, so what we need to do is we sketched out the rectangle, and we got to write the area as a product and area as a sum. So you're going to study this in geometry a bit. It's something called area addition. In that, area can either be represented by, well, the formulas we know, right? Length times by width could be one way we can write this area here. So I'm going to do that first. Length here is y plus 1 plus x, and our height here is x plus 1 plus y. And that's one way I can write area. Another way I can write area is by adding up all the individual areas here. So adding up, each of these pieces have an area. They're named by their areas. So if I add up all these individual pieces, that should give me an equivalent way that I can talk about this particular collection of terms, these algebra expressions that I have here. I have 1y squared, I've got 2 y's, I've got 2 xy's, I have an x squared, looks like I'm going to run out of space, I have 2 x's, and I have a 1. Okay, so time to talk about these words, time to talk about sum, and time to talk about product. Again, area, you're going to study that in geometry quite a bit, but you can represent area of any complex shapes in terms of the formulas you have, right? For a rectangle, we have a formula, and the formula is the product of length times by width, or vice versa, width times by length, that's fine, or base times height if you want to look at it here. So we get from here and here, we get what we're going to call the product. Okay, that other way, other than just multiplying length times by width, another way we get the area is adding up all the areas of the individual pieces, and that should be an equivalent way of getting the area. So that's going to be over here, right? We added up all those pieces, and we got the area as a sum. Okay, next up here in our learning log, it says explain how you know the product and sum are equivalent. Title this entry as area as a product and as a sum and label it with today's date. So I'm going to do that down below here. One way that I actually know that this is equivalent is kind of a complicated one here. I could actually multiply these two together. I could technically multiply these two together and I would get the same thing. I guess one way I could do it is by double checking, right? Double checking if I multiplied any of the terms from the outside to one another, it would match the term that's on the inside. So y times by y equals y squared, and y times by 1 equals y. Y times by x equals xy. 1 times by y equals y. 1 times by 1 equals 1. 1 times by x equals x. X times by y equals xy, x times by 1 equals x, and x times x equals x squared. So here's how I'd kind of answer this question right here. Okay, so here's what I'm going with here to answer this. Explain how you know that the product and sum are equivalent. This is the best as I could kind of word it out. Perhaps he worded it better than me. We can be sure that the product and sum are the same because if we multiply each term of the product to one another, it's going to match each part of the sum. Now, the one that I had here was a little bit complicated because my rectangle was basically like 3 different terms high and 3 different terms wide. But perhaps we try this with a slightly easier one here on the left side. What if I had this as my rectangle right here? Well, in this situation, I would have a rectangle that's a lot easier to check because it's a lot smaller. And this is actually a rectangle that you did in the classwork in your very last problem number A of that. And this one here is a lot easier to double check. So if I have here x plus 2 times by x plus 1, we can pretty simply see that that is actually going to match up with x squared plus 3x plus 2. Because, right, we know that x times by x equals x squared, and we also know that x times by 1 is x, so x times by 1 is x, x times by x is x squared. We also know that 2 times by x is 2x, and 2 times by x is the 2x's right here. And finally, we know that 2 times by 1 would equal 2. And that would simplify to this right here, right? This would just be this with combined terms because this is where we get 3x's here, okay? So we know that they're the same because if we multiply each part of the product to the other parts of the product here, we arrive at the same thing as the sum. Finally, it says title this entry as area as a product and as a sum and label it with today's date. So I'll go ahead and do that. Put today's date. I'm filming this in the summer, I'll be honest. Happy July 28th. Label that up. You got yourself a finished product for the learning log, problem 347. Hey, also want to mention this here too, right below the learning log. You see little math notes right here. So definitely make sure that you're doing this, you're doing the learning logs, but then even more importantly, you're reading the math notes just to check to make sure that the lesson made sense to you here. So I've included that down here below. It's math notes you're listening here too. So make sure you listen to, you read it because it is very important. It's just going to tell you exactly what I told you earlier during this video here. But just to remind you that the area of a rectangle can be written 2 different ways, and be written as a product of its width and its length or as a sum of its parts. For example, the area of the shaded rectangle right can be written 2 ways. We have here, the easy part is to tell what the sum is, because this is 8, and we would get x squared plus, and we 4x's, another 2, 6x's plus 8. Harder part is, how do we get the outside? How do we figure out what the product is? And we can logic through it. That x squared piece means it's x times by x. 2x is up here. We get a plus 2, and we get plus 4 over here. So that tells us that this outside here, x plus 2, is equivalent to the area as a sum, and we're good to go. Hopefully you enjoyed this lesson. People generally like kind of making those rectangles and figuring out areas of product, areas of sum. It's kind of like a little puzzle. I really enjoy watching people do that in class. And hopefully you understand this lesson. If not, reach out if you need any help. Take care, guys. Have a great day. Bye. Okay, hey guys, wait, I'm back here for a second. So I know I do this for a reason, but I noticed here that I forgot to talk about one of the three words that I meant to talk about today. You should know what a sum is. You should know what a product is. If not, rewatch the video, ask questions. But one thing I didn't talk about is this word factoring. You might have been like, well, I actually haven't seen that at all this year. I might have an idea about what factoring a number, for instance, looks like. But what might factoring have to do with algebra tiles, this thing that we're looking at here? So I meant to at least talk about that because kind of what I did here, which I erased here from earlier, but if you remember what I did earlier when we started out with this thing as a sum, and then we found what this is as a product right here, that is actually something called factoring. We'll be doing factoring all year, but more importantly, we're going to be doing that second semester. So this is kind of just a basic introduction. So factoring, a basic definition of what factoring is determining the terms that multiply together to form another expression. So in this one here, we started off with a sum, right? And a sum is a mathematical expression for a number of terms, right? A number of variables and constants that we have there, numbers that we have there. So when we're factoring, this expression that we have up here, we're going from it as a sum and we're determining what are the terms that need to multiply to one another to become this sum here. So I do this as kind of a brief introduction, but we're going to be using these rectangles here all year, specifically in second semester, to determine what are the things that need to be multiplied together to become this sum right here. So the outsides of this rectangle, we're calling them the products together as of now, but the product is made up of factors. So this is a factor and this is a factor once we determine it there. So the process of factoring is going from sum and determining what the product is. And the product is made up of the factors of the sum. So without further ado, let's do it again. Our factors here are going to be x plus 4, because that's the dimension of the bottom of the rectangle, and then x plus 2. And we know that they're factors because they multiply to one another to become this larger expression over here. And we can double check that in our heads. We can double check that by building out another rectangle and multiplying. But we know that we can get our factors, with x plus 2 being one factor and x plus 4 being another factor, that would form this larger expression right here. Okay, so just a brief introduction to factoring right there, going from sum to product. All right, and with that, I'm out for sure. Good luck on your homework. Take care. Everybody.